Welcome back, everyone, to Data Science for Everyone. Today we're going to be talking about experimental research. Let's get started. So let's first off with a bit of an introduction. So before we decide to embark on experimental research, we're going to need to be sure about what you are going to do and the level of control that you have over the situation. Experiments are possible on systems with stable functions, variables that can be systematically controlled. The human condition does not fall into this category. Control is going to be important. An experiment is a controlled research situation, which means that first, the unwanted variables and external influences can be kept out of the experimental environment. Two, the researcher can establish the experimental conditions down to the smallest details. When these conditions are not entirely met, then the researcher has a responsibility to identify the extent of the error. Experimental error occurs when a change in the dependent variable is produced by any variable other than the independent variable. Experimental research, we are going to be dealing with a number of different variables. The independent variable, IV, is the phenomenon or situation that is manipulated by the researcher. The dependent variable, DV, is the behavior or effect that is measured by the researcher as a result of that manipulation. The moderator variable, MV, is the factor which is measured, manipulated, or selected by the researcher to determine whether or not it changes the relationship between the independent variable and the dependent variable. The control variable, or CV, is a potential independent variable that is artificially held constant by the researcher throughout the experiment. The nature of causality. Experimental research is an attempt to establish causality to prove that the dependent variable is a direct result of the independent variable. In order to demonstrate causation, it is necessary to show that the effect of the dependent variable is not only preceded by the cause, the independent variable, but that the independent variable produced the dependent variable and will do so repeatedly, temporal precedence being essential. Causality is essentially a theoretical concept, a hypothesis that is impossible to verify empirically. Perhaps the best we can do is to note the covariations together with the temporal sequences. But there is a mere fact that the independent variable and dependent variable vary together in a predictable way, and that the change in the independent variable always precedes the change in the dependent variable. This can never assure us that the independent variable has produced a change in the dependent variable. Covariance is the empirical equivalent of causation, and the closest we can get to the demonstrating the relationship between phenomena. An experiment is an attempt to empirically verify and corroborate the hypothesis of the causal relationship between variables. Experiments cannot demonstrate causation, only covariance. They are designed to measure the degree to which a relationship exists between the identified variables. Covariance assumes temporal precedence and the independent variable and the elimination of all other variables from the research context. For this reason, only a laboratory setting can offer a suitable environment for the true experiment. Here, test variables can be controlled and unwanted variables removed. This allows the inference that the dependent variable is the direct result of the independent variable. The basic method of a true experiment includes the subject of that experiment, the independent variable, and the measured dependent variable. A true experiment is not only to demonstrate if X then Y, but also to demonstrate if no X then no Y. If the researcher succeeds in providing evidence that both of these statements, then X has been isolated from the potential causes of Y. That is to say that the treatment or cause can be seen to be the only phenomenon acting to create the identified effect. This means that there have to be at least 2 clean tests carried out on random groups at the same time in order to measure y as a direct result of x. One test involves the subject being exposed to x, then measuring the outcome, y. The second test, or the control test, involves a subject not being exposed to x and identifying and measuring the outcome. It also means all intervening variables are controlled, if not eradicated, and then measured to determine the level of error indicated by these variables. Here we see a basic, simple design of a simple experiment. We have a randomly selected sample. This gives into random assignment, and then we have our questions of x, then the measured observation of change in outcome 1, or not x, measure the observation of change, if any, in observation 2. Quasi-experiments differ from true experiments in purpose and process. Where true experiments aim towards covariance, quasi-experiments aim to establish levels of correlation between observable variables. Correlation is used to identify both the degree and direction of a relationship, a scaled version of covariance which makes no temporal assumptions. True experiments involve deliberate manipulation of the independent variable, whereas quasi-experiments or correlation observations do not intervene and aim to identify correlation between variables as they exist, with no temporal restrictions. The non-equivalent group's design is similar to the basic true experiment design, the only difference being the selection of study participants and the location of the study. The time series design follows the basic design of the non-equivalent group. The difference here is that the observations are made at a number of time interval pre-test and a number of time interval post-test. Longitudinal observations provide substantially more observational data and more detail on progressive change or continuity. True experiments are used to trace cause and effect relationships between predefined variables. As such, they rely completely on controlled variables. This requires conditions where the researcher is in complete control of all independent variables, being in a position to add, remove, or manipulate in some way or independent variable in order to trace the effect. Causal inference poses significant problems when we're dealing with the human condition. Many variables will always remain outside the control of any research, as cognitive, affective, and social variables relating to the individuals are almost impossible to predict and certainly impossible to control in most cases. Any research of this nature that involves humans in social settings will be quasi-experimental at best. Only those entities that remain under the complete control of the researcher can be used as a basis for true experimentation. Your goal with this type of research is to demonstrate correlation, not causation. If you guys like this video, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.